Hi everybody, how we doing? Today we're going to be talking about the laws of exponents. Basically what we're talking about is how do exponents work and what do we have to do when we're using them? Are there guiding principles that we use when we use exponents? And yes, of course there are. So let's start with an example problem. Let's start with x squared times x cubed, which is another way of saying x times x times x times x times x, which is another way of saying really just x to the fifth, isn't it? What I want you to see here is x to the fifth is just a shorter version of x squared times x cubed, but they're equal to each other because x squared times x cubed really is 5x's being multiplied together. So what can you do with x squared times x cubed? You can make it x to the fifth, and you might be noticing something interesting about those numbers. Well, let's look at another example. What if you have n to the fourth times n to the sixth? We could write that out and expand it. We know n to the fourth is n times n times n times n, and n to the sixth is n times n times n times n times n times n, and that basically means we have n to the 10th, because there are 10 n's all being multiplied together there. Notice that you started with a 4 and a 6 and you ended up with a 10. And when we had x squared times x cubed, you started with a 2 and a 3 and you ended up with a 5. Interesting. Something happened there. What was it? Well, here is the law of exponents that applies to this situation. If you have x to the something times x to the something else, what do you do with the first exponent and the second exponent? The laws of exponents tell us that we should add those two exponents together to get a sum, and then we can shorten up the whole expression and make it nice and tidy. So we added the 4 and the 6 to make n to the 10th, we added the 2 and the 3 to make x to the 5th, and this is a law of exponents. Now, if you can't remember this law of exponents, you're okay, because when in doubt, just write it all out, and then you can add it up and you'll get the right answer. But the law here gives us a shortcut so that we don't have to write it all out. Okay, so here's another example problem. If you have d cubed times p squared times d squared times p to the fourth, what we really have here is d times d times d, and then later there's another d times d, so we have d to the fifth, and then p squared in there, p times p to the fourth, which is p times p times p times p times p. Okay, so we have 6 p's there and 5 d's. So do you see why we can just summarize this as d to the fifth, p to the sixth? I think you can, but just in case, when in doubt, write it out. Wouldn't this be d times d times d times p times p times d times d times p times p times p times p? Yes, and now hopefully you see why we can just shorten it to d to the fifth times p to the sixth. It's the law of exponents. What do you do with the exponents? You add them up. Now, do we add the 5 and the 6 here to make an exponent 11? No, because the 5 stays with the d's and the 6 stays with the p's. Hopefully that makes sense too. All right, let's just try one more. What if you have 2 cubed times 2? Let me try that again. What if you have 2 cubed times 2? Well, isn't that second 2 really like 2 to the first power? And in this case, wouldn't we add the 3 plus the 1 to get 2 to the fourth? Sure, but if we're not sure, wouldn't this be 2 times 2 times 2 times 2? Okay, that is 2 to the fourth. Yeah, you just add the exponents. The laws of exponents tell us that we can add, and that makes these problems really easy. So we could say 2 to the fourth power is 16, or we could just call it 2 to the fourth power. How about you try a couple? What if you needed to do this and simplify it? Or what if you needed to evaluate this? In other words, tell me what this comes out to if you multiply it all out. Try those, and we'll check our answers tomorrow. Okay, what about a division problem where instead of x to the sixth times x squared, it's x to the sixth divided by x squared? In this case, what are we going to do? Well, we could, when in doubt, write it out. We've got 6 x's on the top. We've got 2 x's on the bottom. And if you notice here, what we can do is just like reducing fractions. If you have an x here and an x here, can't we just scratch them? And then you've got another x here and another x here. Can't we scratch those out? They cancel each other out, right? Okay, good, good. So what do we have left? We have x times x times x times x. That's just x to the 4th over 1, which is really just x to the 4th, isn't it? Interesting, we started with a 6 and a 2 and we ended up with a 4. The law, in this case, tells us that we take those two exponents and we subtract. We do 6 minus 2, and that gave us our 4. The laws of exponents tell us in this situation that we should subtract the two exponents when it's a division-ish problem like this. Now again, what if you forget the law? It's okay, when in doubt, write it out. So z to the 14th over z to the 7th should be z to the, what's 14 minus 7? Z to the 7th, because 14 minus 7 is 7, and that's the law. You do 14 minus 7 equals 7. Okay? What if you have a to the 30th over z to the 12th? Do we do 30 minus 12 in this situation? No. Because a's and z's don't mix. So in this situation, there's nothing you can do to simplify it. You just leave it the way it is. All right. What if we do have some different variables, but we have some same variables too? Okay, take the ones that are the same and subtract their exponents. So x cubed on top minus x squared on bottom. 3 minus 2 is 1. And x, or with the y's, you have a 2 on the top and there's an invisible 1 on the bottom. So 2 minus 1 is 1. So really there's just x to the first, y to the first. It's just xy. Should we write it out just to show you why? Sure. X cubed y squared on the top is xxxyy. And x squared y on the bottom is xxy. And we can just match up and scratch. Match and scratch. Match and scratch. There's a match. We scratch them out. What's left? There's an x and a y over a 1, which is really just xy, which is like x to the first, y to the first. And I think you get it by now. So simplify this. Do something with that 6 and that 3. And then simplify this. You got some s's, you got some t's. This is going to be s to the what, t to the what. If you can do these problems, you're all set. And that's all we've got for today. So thanks for listening, and I will see you tomorrow.